Hello everyone. Today we'll be parallelizing the Fast Fourier Transform Algorithm using our interactive parallelization tool. We'll be parallelizing this for loop right here into a CUDA equivalent. So let's start by running the translator. The translator will ask us which parallel programming language we want to translate our serial program into. For this demo, we choose 3, or CUDA. Now it asks us which function we want to parallelize. Since we want to parallelize this for loop, which is in our main function, we can enter main. And since it's not a nested for loop, we can just go with option 1. Now this will prompt us with the list of for loops until we reach the selected for loop. So right here, we have our selected for loop, so let's say yes. After selecting the for loop, we will now be prompted to enter the size of the array. Since the array we're parallelizing have a size of 2 times n, that is what we will enter. Now, we must specify whether each of the following variables are input, output, both, or neither. So, since our variables x and z are arrays, we want them to be input, output. So let's select option 3 for both of them. Now, the translator will produce the code inside the for loop as it would appear inside the kernel call. So let's take a look at our output file. It's vi, then underscore FFT.cu. And looking at it here, we can see that we have our malloc calls for our device arrays, the dim grid and the dim block, which specify the number of blocks and threads that need to be run, and the memcopy for the CUDA variables from host to device, then our kernel call, and finally we have the original for loop commented out along with the memcopy for the variables back from the device to the host. Now let's take a look at the kernel. That would be around line 15. Right here we have first the calls and the rows that are being calculated. Then we have our for loop code right here. Now note that the for loop code, we have replaced the array indices with call instead of the original for loop index variable. Thank you for your time.